3 independent simulation teams trying to solve the same problem. And the question here is just how many galaxies form in a halo at redshift 0 at the present epoch. And down here is showing you the mean behavior that's fit by these lines. And they're off a little bit in normalization, but the shapes are actually pretty similar. And so what we do is we go through and we do statistical analysis by doing what's called a local linear regression. We don't do a linear regression for all the data. We put a filter where we analyze a little region in halo mass and then pull out the local slope and the local scatter of the population. So here's where the population statistics of massive halos, old title, comes into play. And this is some of the results that we published just earlier this year. And we continue to work, and I'll show you a slide on some work that we've been doing with even more simulations than the list shown here. But the local slope, you can see these numbers are the different simulations give numbers that are in pretty good agreement. Here's 1, 1.1, 0.9. It's only a 10% range. It would be better if they would agree even, more than they do right now. But that's this is the hard problem. This is a non-trivial problem to solve. So the fact that they're this close right now is, I think, encouraging. Similarly, the case of the scatter has a similar behavior with slight differences across the simulations. But the main reason what we emphasized when we published this paper was this common feature, that the shape, this is kind of very subtle, but it's saying that when you look at the deviations and you normalize them by the standard deviation at that mass scale, and then you can collect them all up and look at the likelihood of deviating from the mean behavior. Here's what the likelihood is. It's the for the different colors is coming from the different simulations. Our best fit is this black line, and then just an underlying simple Gaussian is this gray line. You can see it's close to Gaussian, but no, they're actually not Gaussian. They lean a little bit. They lean a little to the to the right, if you will, and there's a tail down to low satellite number. Okay. And we fit it with what's called a Gaussian mixture. So there's a little Gaussian, a broad, low Gaussian here, and a more peaky Gaussian there in gray. And that's the model that we presented to the world for our colleagues to use and go forward with. So that's the distribution of the number of satellite galaxies. It's even simpler when you look at the total stellar mass in the halo, which is this quantity m star. M star is very simple in that it's very Gaussian distributed in the log around the mean. So these kind of distribution functions are extremely useful for making analytic predictions of modeling of survey yields, for example, from galaxy clusters identified in optical surveys. Okay, now, just to give you a little bit more detail of where we're going with this, and this is a paper in preparation that DIA is leading, is that we decided to look at other properties, not just the number of galaxies in a halo, but let's look at something that observers can go out and measure as well, which is their motion within the halo. So we look at the pairwise galaxy velocity, so the central galaxy minus the satellite galaxy velocity, that's I being the central, J being a satellite. We write that as a convolution, where this sigma is this is a Gaussian distribution, and sigma is the width of that Gaussian. And then we let the widths of the Gaussian vary as a function of mass and redshift, with a parameter that's a normalization, that's down here, a parameter that's a slope, and an intrinsic scatter in that parameter, the velocity dispersion. And then this is the mean behavior. Okay, and then we can go ahead and make all these measurements. And we did that not just for our TNG and Magneticum and Bahamas and Naxos, that we named these guys before, but those are the 3 that we originally started with and published earlier this year. But then we went out and contacted other folks with similar simulations, more recent ones, and picked them up. So there's a group called the 300, and a group, this is not University of Michigan, this is the Universe Machine is the name of that simulation. And this is a little bit of a complicated plot, but I'm showing you first up here the normalization, the slope, and the degree of scatter about the mean relation. And what we're looking at are populations of galaxies that are thresholded by stellar mass. So we range in stellar mass from 10 to the power 8.5, which is about factor 30, or about factor 10 smaller than the Milky Way stellar mass, up to 10 to the 11, which is much bigger than the Milky Way stellar mass. And the main thing that we see that is also confirmed, at least initially by some observations, is that as you go to brighter galaxies are cooler. They move at a lower velocity dispersion in their halos, and we believe that this is because the biggest galaxies tend to form earliest, and they form at the centers of their parent halos, and as opposed to some of these lighter galaxies can form much later and get accreted at later times and don't spend as much time sort of cooling down in the gravitational potential. These guys spend a lot more time in the gravitational potential, and there's a process called dynamical friction that sort of slows them down over time. So, and what we can also see is that the slopes are pretty consistent, and the degree of scatter, at least at low, and I should have said the colors designate a time or redshift. So the present is redshift 0. We also look at redshift at half and redshift at 1, which for galaxy clusters, that's about as far as we can see large samples of galaxy clusters, is out to redshift at 1. We're now just exploring between redshift 1 and 2 with current surveys. So this is sort of aimed at our observer colleagues to sort of get a sense of what kind of velocity information we should get from next generation surveys. All right, so that, believe it or not, was the bleeding edge that I wanted to present to you from simulations. And you might go, well, really, that's the bleeding edge? Well, I would argue that this is bleeding edge in the sense that multi-simulation studies of the type that we've done are actually pretty rare in the literature. And it's really because they're hard to do. We were fortunate in the sense of having, we're looking at a high-level derived property. We're not having to go directly into the simulation output and measure everything ourselves. We're letting our colleagues make the measurements. The people who have done the simulations themselves make measurements. We make sure that those measurements are consistent, but then we can just collect up catalog-level information, which is a lot simpler than starting from the individual particle and cell output of these very large simulations. Our work really illustrates that there's pretty good convergence across multiple simulation teams for these kind of very non-trivial halo properties. The number of galaxies in a halo, their velocity dispersions are not, you can't write down using pencil and paper what the answer will be. You have to do these simulations to find out what that answer will be. And so it's non-trivial, and the level of agreement is really quite impressive. And then I think where we're trying to head with this is that the kinds of survey data analysis that are being done right now are often very agnostic as to exactly how many galaxies are in a halo, exactly what the distribution, what is the form of the distribution of the likelihood number of galaxies given halo mass, what does that look like? The current analysis methods are really kind of loose with respect to the priors on those parameters, and what we're trying to do is inform those parameters to tighten them up, which will then yield more improved estimates of measurements like omega matter, omega lambda, the key parameters of the density in matter and the density in dark energy in the universe. So that was my second part of the talk. Maybe I could pause and invite any comments or questions before finishing out with research on grade inflation.
The asymmetry in the number of satellite histogram, you think that's due to the accretion of the satellite galaxies or something else?
Yeah, we actually, in the paper, we show that this tail is correlated with the central galaxy. So these are satellite galaxies, meaning it excludes the central galaxy in the halo. And there's a correlation between this tail of low satellite counts. These halos also tend to have a higher mass central galaxy. So it's essentially the central galaxy has eaten away. They've merged if a lot of satellite galaxies merge with the central galaxy, they just add to this central galaxy stellar mass, and you lose counts of satellites, and that's what constitutes this tail. And you see the total stellar mass is unaffected, right? Because we're counting both the central and the satellite galaxies over here. Good question.
Aren't there different data sets for modeling dark matter?
I'm not sure what you mean by that.
Okay, I'm going to have to refine my information because I'm a little vague on the whole dark matter thing.
Well, I think there are the canonical approach to dark matter is to say that it's a weakly interacting massive particle, or a WIMP, right? Now there are other possibilities. Some range of primordial black hole masses remains possible. Axions remain possible, but axions behave just like a weakly interactive massive particle, and so do primordial black holes. The whole idea here is that you want the material to gravitationally cluster, but not interact strongly with itself or with ordinary matter. So that's pretty much the way that the whole community, the way that these simulations model dark matter is common to the way that all simulations of this type have modeled dark matter.
One other question. In your models, do you ever use the, I can't remember the term for it, but it's a type of dark matter theory that it annihilates with itself?
Self-interacting dark matter.
So any of your models take that into account, or is that something completely different?
Yeah, actually, one of the it's a very similar approach. One of the co-authors on this work, Ian McCarthy in England, is doing self-interacting dark matter simulations as well. What you do is you turn on a little bit of interaction because the current constraints from objects like the bullet cluster of galaxies don't allow for there to be large cross sections for dark matter interactions, but you can still have some. And what it tends to do is it tends to kind of lower the central density of the halo and make the halo maybe a little more spherical. So I think for these kinds of statistics, you wouldn't see much of a change here. And I should say, yes, we are all of this work is trying to expose what we expect for the canonical WIMP dark matter case, because that still remains the strongest candidate for dark matter. Okay, why don't we move on to the horror of weight inflation? And you'll see Bayes' theorem again here. It's kind of amusing. And this is work being done with Kate Holman and Kyle Schultz in the Center for Academic Innovation. So this came out of my work with those folks building what's now called Atlas. And Atlas started in 2016 as a reboot of a service that I brought to campus in the College of LSNA back in 2006, which was called Academic Reporting Tools, and it was aimed at faculty and staff. And it was basically visual dashboards of behaviors, right? Although we didn't call them dashboards back in 2006. My good friend Tim McKay helped get some money from the Provost's office in 2015 to build what was then called the Digital Innovation Greenhouse, and the Digital Innovation Greenhouse essentially evolved into the Center for Academic Innovation that is now a very large center on campus, headquartered at the top of the library, 8th floor of the library. And so we went live in 2016 with a service that was the first service directed to students called Art 2.0, which now is called Atlas. And Atlas does things like serve information about courses, and here's an example. Our Physics 160, our honors physics course, the Provost's office and the Senate Assembly got together with student government in 2016 and agreed that student evaluations of teaching could be released back to students. And so what we do is we just show very quick summaries of the questions that are asked in the student evaluation of teaching. And here's examples of the types of questions that are asked about a course. You know, I had a strong desire to take this course, and you're given a Likert scale from strongly disagree to strongly agree, right? And what we end up showing is the fraction of students who agree or strongly agree to any of these questions. And so, you know, you see honors physics, there's a more strong desire to take it. And, you know, it's tough to increase people's interest when their interest is already high. So, you know, often what you'll see is that, you know, if this is more like 50%, you look to see that you can get this above 66%. You know, that's the challenge. But there's also things like the workload. In this case, it's a little bit higher than average. Did it increase your understanding? Were the expectations clearly outlined? And then scrolling down the page, you get other information. And one of the most useful things for both students and faculty is to see what did students take before taking Physics 160, what do they take at the same time, and what do they take after. And in this case, taking the lab makes sense, that's required. And then 260 is the next semester. And we see that only 43% go on to take 260, so that's, you know, maybe we should try to increase that fraction. Along with these, you know, sort of pages about each course on campus, this is not just LS&A, it's all of the units except the med school. So we have 19 schools and colleges, so we serve 18 out of 19. There's a deck of cards for, you know, each course has a page, each instructor has a page, and now each major also has a page. And what I'm showing you is the Bachelor of Science in Computer Science, and we show things like what's the number of students who graduated with that major, and you can see, you know, starting in 2009, you only had a handful, and then it just grew by a factor of 10 in a decade, right? And continues to grow. This is a graph that I made last year, so I didn't update it for tonight. We show what the common co-majors are for that degree, how many semesters it took to complete, either with a single degree or with multiple degrees, right? So it's very useful information, and it's exposing all of this information that the university pays a lot of money to hold, in the sense that, you know, there's a whole enterprise unit that manages all this information. And so for a little extra money, what we can do is pull it and package it and send it back out to people to make sense of it. And here's a Google Analytics slide showing that we get a fair amount of usage from students. So when we first rolled out, this is the counts of users per week. You know, we were maybe at 1,000 or so. And then you can see when backpacking happens, that is this times that students are planning for the courses they're going to take next semester. So there's a bump there and a bump there, and a bigger bump and a bigger bump. And so, you know, in peak times, lately we've been running at about 10,000 users per week. Okay, grades. So as part of this Atlas project, we had a poster in a provost, what do they call it? Provost Seminar on Teaching, PSOTS, Provost Seminar on Teaching. In 2018, we showed a poster where we showed how grades are rising on campus. And so here, the color shows you year running from 2013 to 2018. And this is merely the frequency of the different letter grades that are given out in undergraduate courses across the university. And you can see A pluses just in that 5-year period, you know, went from 6% up to 9%, right? A's increased another 5%, and, you know, at the expense of basically low grades, right? So grades are rising. Now they are pretty much rising everywhere, but there's still a differentiation, you know, among the colleges and divisions. So here I'm just showing you, for example, this x-axis is the percent of A grades handed out for undergraduate courses. The y-axis is the percent of C or lower, and then the fraction of B's is given by these lines, right? Because the whole sum has to be 1. And essentially what you can see here is things like education, public policy, school, music, theater, and dance are pretty high on the A range. Natural sciences in the med school, not so much, and they give out of order, 17% C or lower grades as well. And then different, engineering sits kind of midway between, in there next to social science. And another way to look at this is to look over time and see how things have changed. So in the same style of graph, percent zero lower, percent A, I'm showing you the grades that were given out in undergraduate courses in 2006 in black and in 2019 in sort of brown. And we're showing you here the grades that are given out at different credit limit, credit count courses. So these are 4 credit courses, 3 credit, 1 credit, 2 credit, right? And what you can see is that in 2006, right, we, here are the black points. In 2019, here are the brown points. So there's been a movement towards more A's and fewer C's or lower at all types of courses over that period of time. But it's an interesting question. Okay, is that what we mean by grade inflation? That the grades are rising? Is that grade inflation? What about the fact that over that period of time, we've been letting in better students? The university has been getting increasingly selective, right? In the sense that, because I remember my daughter went here. She graduated about 4 years ago now. And so matriculated here about 8 years ago. And I remember going to the Chrysler Arena and sitting there with her at one of the ceremonies where you're welcome to Michigan. And whoever was talking, whether it was a dean or a provost level person, was saying, your class is the best class we've ever brought in. You have the highest ACT and SAT scores. And it's like, okay. And I think they just did that every year, right? Every year the class just got better in the sense that the selectivity got higher. So how much of the rise in grades is due to the fact that the students are better versus, the faculty maybe making things easier or something, that also the faculty are doing. So that's what we're trying to get at, is to understand to what degree has the enhanced selectivity caused rising grades. And the way we're going to go about this is with some statistical games. What you can see is in any given semester, this is 2017, for example, is that a student GPA correlates with their ACT score, and if I showed you SAT, you'd see the similar thing. Every point on here is a student, and you can see that there's a regression line that basically says that, if you're a good student, you get good grades. You test well. Let me put it this way: if you test well on a standardized test, you're going to test well in courses too. And so, it's a weak trend line, but it's there's a lot of dispersion, but that trend line is certainly there. And it's pretty persistent. So if you look at the correlation coefficient between grade ACT and grades earned and SAT and grades earned, it's been pretty constant. It's weakly declining with time, but it's a mild correlation. Right? So what we are going to do to address the question that we're framing here is once again use Bayesian statistics. And here T is now a time, G is a grade, and S is a score on the ACT or ACT test. And here we have, again, our joint probability distribution of grades and scores in a given semester. We can break that up as a conditional probability, right, times the individual score distribution, right, distribution of scores in any given year. And this statement is true for every year. So our model is going to pick a reference here, and we're going to measure this conditional, correlation here. And then what we're going to do is apply that conditional correlation to every year's selectivity, the likelihood of getting into the university given score, right, as a function of time. And then that's going to be our model prediction for the joint distribution of grades and test scores. And then we'll create a predicted grade based on just taking this model and summing up the grades that we get. Okay, that's 3 equations, that's it. And so here's the answer. The actual grade rise as a function of year is this black line. And it goes up, almost 0.2 in, a little over 0.2 in 13 years. And our model running forward is shown by this gray line. You see that it rises about 0.1. So we make, we would argue that about half of the rise in grades on campus is due to just increased selectivity. This yellow line is we can play the same game, the same statistics game, but use our reference point as the end year, 2019, and then run the model backwards. And you see it's a little bit we get a little bit less of a fraction responsible to selectivity from running it backwards, but it's a very similar result. It's like 0.08 instead of 0.1. So really, the point of that kind of analysis is to really change what we mean by grade inflation, right? Because we want to identify the student-related component, and then that will allow us to understand better what is the faculty's role in grade inflation. And I'm not going to show you because it's still sort of work in progress. And by the way, I should say that this result and the previous result I showed you from DIA are really fresh off the press. They haven't made it into a peer-reviewed publication yet, but we're writing this result up for a learning analytics and knowledge conference that's coming. The deadline is in a few weeks, so we're getting this ready for publication. And then, so one of the things we find is that STEM subjects in business actually have lower faculty-related grade rises compared to other divisions, in particular humanities and social science subjects. So that's pretty much what I wanted to share with you tonight, and I'm happy to take questions about either virtual worlds or Atlas and grade inflation. Thank you.
Well, I have a comment about the whole grade inflation phenomenon. I didn't care much about grades. I cared about learning. I learned most of my chemistry in high school, and then when I got into honors chemistry in college, I was more interested in things like quantum mechanics and so forth, and the foundations of the foundations of reality. Fortunately, I had a professor that recognized that and graded according to not just on quantification, but on his subjective perception of what the student was learning. I had other professors who went pretty much by quantification, and it required a difference in my concentration on what I was studying. So I feel that the whole grade thing is just so corrupted, and I really see no solution to it other than individual professors recognizing the intellectual engagement of their students with the subject.
John, I appreciate your sentiments about grades. I think I am so tired of like keeping track of points after 30 years. I really would like to, essentially find an alternative. Difficulty is one of that. Your experience you're recounting sounds like it was probably in a relatively small class. I mean, if you have 20 students in your class, you can get to know the faculty member, instructor can get to know.
I did. I had very small classes.
Yeah, so in small classes that still works and still happens, meaning that faculty can get to know their students as individuals and really kind of evaluate them in ways that are much more nuanced, right? When you have a class of 700 students, there's no hope to be able to do that, and so it's not that we have many more 20 student classes on campus than we do 700 student classes, but if you look at the credit hours and the what students take away on their transcript, more than half of what's on their transcript comes from courses that probably where they had more than 100 students with them in class.
Well, that's
so
for my daughter who was an outstanding student, graduated from Interlochen Arts Academy and could have gone to any school in the country, really. She chose to go to a small private college, Boyd College in Wisconsin.
Right.
Because of the personal nature of the engagement there, but the opportunity for extracurricular activities that are life fulfilling. We gotta live, and unfortunately, I think that often 4 years of undergraduate study just takes 4 years of life away from a person.
Mm-hmm. I guess I have to speak in defense of the University of Michigan, my employer, for the moment. The slides that I showed you that Daya Ambajagini's work, his honors thesis. That's an example of a case where he has no, on his transcript, you can't even see that activity because he was a work study, he had work study, and I was employing him through work study to do that work. And yet, to his, the fact that he got a publication while an undergrad is one of the factors that got him into graduate school at the University of Chicago. And so, in the interaction that he experienced in my mentorship along with Arya was very much the three of us. We would have hour-long telecons once a week. We still do. We have in fact, I meet with him more like 2 or 3 times a week sometimes, and so that there is the possibility to engage in a very personal level at the University of Michigan, faculty and students. It's just that I think not every student takes advantage of that because the numbers don't work out. The faculty-student ratio is still pretty good at Michigan, but it's not going to be as good as some of the smaller liberal arts colleges out there, which try to keep it 10 to 1 or something like that. Right?
So the book on Michigan is if a person, if a high school senior really knows exactly the career that he or she wants to go into and is highly motivated and has a distinct direction, has that maturity, University of Michigan is an outstanding environment for that kind of person. Unfortunately, that's not your typical 17 or 18-year-old. And one of the problems the University of Michigan has is that frankly people don't lost. It have wonderful faculty, vouch for that, wonderful opportunities, but if you aren't ready to stand on your own 2 feet and march along through your career, you may be in difficulty.
Understood. Yeah. No, it is a very big place, and it's easy to sort of go through the motions in terms of make sure you have a degree pathway, but especially for some of the more common degrees, psychology is actually not as popular as it used to be. And in fact, the most interesting but 10 or 20 years ago, it would have been like we were pumping out all these psychology graduates, and where did they go? What did they do? Yeah, it's. I think we are. I can't speak for the administration. I'm only a faculty member. I can say that we're trying to get better in terms of both mentoring students and as they, our physics department, we're trying to do a better job. We do have a very small number of physics majors, and also astronomy has a similarly small number of majors. And so I would say that the majors if you choose a major like that, where the faculty to student ratio within the major is small, then you can get that small college experience. And I think maybe that's what you're suggesting, is that if you know you're going to do astronomy and you go to Michigan, you're going to have a pretty good time because it's there's 12 or 13 faculty and maybe like 15 if you include me and some others in physics. And then they typically graduate about 15 students a year. So, that's almost 1-to-1. So that's pretty solid.
Well, that's another thing, because in the STEM fields, often a person is, when he's younger, when he's 18, 19 years old, he's not prepared to do the intellectual work that he may be prepared to do at the age of, say, 20 or 21, when there is a rather expanded ability to concentrate and to learn, and there's less diffuse thinking, less ADHD or whatever they want to call it. But that's one of the problems that STEM has, is that I think people get filtered off too early. DivvyQ fails too many students instead of too many students failing different people.
Yeah, I don't have a solution. Yeah.
Any other questions? Wow.
Well, because I'm a big mouth on the scene here, is that I went to the University. I could have gone into a lot of different schools, but I went to the University of Toledo because my girlfriend couldn't afford to go anywhere else, and I was hopelessly in love. And I had the best educational experience that I think I could have had. I had small classes. I had professors. We engaged in the the cafeteria after classes. It was intellectually, it was outstandingly engaging. And that was a commuter school for kids who just wanted to get a degree so they got a job.
So I went to University of Chicago, where the entire program is designed to take you out of your comfort zone. And I had to take in my first 2 years of college, even though I was a history major, astrophysics, genetics, evolution, calculus, and biology in my first 2 years. I had my biology professor actually encouraged me to switch my majors. And I'm just saying that I don't know how Michigan is organized. I knew a lot of people in Michigan when I worked in Detroit, and I met many students there who did not take advantage of the university, concentrated on their major. And I think it would do any university good. You don't have to adopt the University of Chicago Common Core model, but it would do any university good to force students in their first year or so out of their comfort zone and expose them to different intellectual pursuits and thought processes. And they may have a life-changing event. I'm trying to remember who that. There was one very well-known historian who went to school as a med student at Wisconsin, and he had to take a history class, and it changed his life. He became a historian. So I'm just saying there's a real problem in modern intellectual life about cross-disciplinary work, because we're also we are living in our own boxes. But forcing someone who's an accounting student to read Shakespeare might do him some good. I don't know what Michigan does in that regard. I'm just saying that was a valuable tool at Chicago. Mm-hmm. I only had 3 classes of more than 50 students my entire 4 years.
And the University of Chicago has an outstanding undergraduate model. I don't know how many people realize that the University of Chicago is primarily a graduate school. Their undergrad school is less than half the size of their grad school. But their undergrad school they really have a intellectually stimulating model for their undergrad students.
Another aspect of it was every professor at University of Chicago, except for Sal Balo, was required to teach an undergraduate class. So my physics professor for astrophysics is a name Gus will recognize, David Schramm.
Oh, sure.
Yeah. So I got astrophysics from David Schramm.
That's great. Yeah.
And so I don't know what the divide is between professors and students at Michigan. Every full professor at Chicago has to teach at least one undergraduate class a year.
Mm-hmm. There is no such requirement here at Michigan. However, I will defend at least my college of LS&A that there are distribution requirements that force students to get out of their comfort zone. Unlike in engineering, engineering or a program like nursing, there the curriculum is just locked into doing essentially what you came for. LSA, tries to promote exploration, and you do have to, if you think you're going to major in history, you still have to get natural science credit. You have to take some classes, but it's not like it isn't structured. There's the student. It's up to the student to select the courses that satisfy those requirements.
I would suggest a university-wide commitment to to force them out of their comfort zone, even if it's just one class a year for their first 2 or 3 years. That would enrich their intellectual life and broaden their perspective.
Yeah.
I remember going to U of M in '97. We had to take electives. So those electives could be in anything. And we also had a football team that was a primary driving force for when people wanted to come to the university. So there were a number of things you could get into just by being on campus, which is why it took me such a long time to graduate from the engineering program. Because if you didn't have a focus, you would get pulled into so many different things. So yeah, the schools, they're all different, but I guess it just depends on what you go to U of M for. And I just remember the 90s. I think your studies started in the 2000s.
2006, yeah.
Yeah, in the 90s, at kind of a different time. And yeah, it was tough, but you also had a lot of help trying to get through there. So yeah, it depended on what you wanted to go to U of M for, and if you were able to go to U of M. I'm still paying off student loans for that, but I still value the education that I got.
You got your engineering degree?
Yep. Yeah, BSc in '97. It was computer engineering.
Okay.
Computer science and computer engineering ran kind of side by side.
Right.
With engineering, we had to take a few more courses on what goes on inside the computer, but we could still program. And then while I was there, I worked as a basically the job that I have now as a system administrator. We had a student you may have heard of, used to work at a place called Kane.
Yep.
And I'm not even sure if that's there anymore. Yeah, that's how we learn. Stuff that Jeff does is, I'd probably be working there under that capacity, but we learned a lot more from having to solve the real world problems of every student lab that we set up. Of course,
I was there at U of M in '88, and I was there in '88, and there's an interesting program called a Bachelor of General Studies, and it's a kind of a roll your own degree program, but you work closely with counselors to kind of focus on something, but allow you a lot of diversity. And frankly, I got in all of my computer sciencey stuff, and I didn't have to worry about the math stuff really killing my grade point average. But it's still around as far as I know, and it's one of those shining stars that nobody really hears about at University of Michigan.
Well, I did. Math was a requirement, and it did kill me. But eventually, I got through it. The programming was the fun part. The algorithms and code. That was cool. The math, statistics.
Getting back to the idea of grades. Unfortunately, Dr. Evrard, I think you're wandering. You've been dropped into a desert with no directions as far as what to do about grading, because we are in such an intensely grade and evaluation and quantifying conscious environment now, intellectual environment now, that it's just that it's a mass environment where the focus seems to be the entire mentality rather than the breadth of consideration of the well-being of the human student.
I want to push back a little on, the fact that Michigan, yes, is big, but I think that our faculty, by and large, the people that I know, respect our students and care about them, and try to make, establish human contact and establish, essentially, in some cases, a lifelong relationship with some of our students. I still remember the undergraduate who who was the first to write a paper with me. This was back in '97. He is now a professor at Yale University who does very similar things. He works in computational cosmology. And in fact, he had produced a PhD student who we recently brought onto our faculty. So her name is Camille Avestruz, and she's like my scientific granddaughter, and she, I when I see her, I think of Daisuke when he was an undergraduate student, her advisor, when he was an undergraduate student. And I try to, I try, especially in these smaller upper division classes, to think about the pathway that these students are on, and how can I help you get, where do you want to go? How can I help you get to that next place? So I think, and I know I'm not alone in trying to be more, to be open and to be willing to, essentially partner with students, to say that this is not a transaction where I speak to you and then you regurgitate back to me, and if you regurgitate everything I said to you in the same way I did, you get an A. And if you, the old teach the test kind of thing. Yeah, most faculty are not into that. But it's the problems are when you get down into the intro level classes where you are now managing a whole production with 200, 400, 700 students per term, and 20 GSIs. Then it just becomes a business, because you can't have any hope of really getting any kind of relationship going with only best is a handful of students. But I would say that at the upper division, it's really, if you have friends or family who have students here, just make sure that they know that it's really up, it is up to them. Like, a faculty member's not gonna walk into their dorms and say, hey dudes, why don't you come and do some research with me? I mean, that's not going to happen. But if a student sends me an email, or if a student knocks on, back in the day, just my door is open. If they, knock on the door and say, hey, can I talk to you for a couple minutes? I will spend time with them, right? And I think that's true for most of our faculty. So, yeah.
I apologize to you then about that comment, because again, I'm thinking, and I guess I should make this explicit. I remember all of the pre-med and pre-law students who were trying to get into medical school period, and trying to get into the best law schools, and how it was just a race for the grade. Undergraduate school was simply a grind. It was not a matter of what you knew or what you learned. It was entirely the grade.
Yeah.
And even at a computer school at the University of Toledo, those kids struggled, and some got into really good schools, but it was all about the grade, the GPA.
Yeah.
And that's gonna be made.
Yeah, exactly. And we saw from the SAT scandals last year, that there's it's not, the university is inheriting a lot of these issues, in the sense that the part of the problem with our increased selectivity is that we are seeing students who have been groomed to essentially perform in this kind of environment. They know where the points are, they know how to satisfy the requirements of canonical ways in running courses, like, okay, you're going to have this number of quizzes, and you're going to have this many tests, and it's going to be this style, and really that's the part that I think many of us on the faculty, we're trying to make sure that we, let's get away from standardized multiple, even though I have another service on campus called Problem Roulette, which serves old multiple choice problems taken from exams in big classes, like the intro physics courses, or the intro stats course, or the intro chemistry course. And they, why do we give multiple choice exams? Because we have 700 students in the class, and how else are we going to evaluate what you know? That's why. Now, would we like you to write an essay along with taking a multiple choice test? Yes, but how do we evaluate 700 essays in a term? It really becomes, it's as simple as that. And when artificial intelligence reaches a point where, the artificial intelligence grader can read your essay and give you a grade, then the question is, well, why do you need a university if you have robots, out there to teach you, but that is it's going to become, or there's going to be the possibility to employ computers in that way, at some point. I don't know. I don't know of any. Well, I think there was a mention already of an auto grader happening in these classes. I'm sure.
I have a different approach to that. My undergraduate education is in economics, so I'm intensely interested in the distribution of resources for the optimization of the well-being of humanity. And I would say what we do is we take some of the billions from the absolutely super rich. We hire more faculty, we educate more people, we offer more people to get the education they need to be educators, and then we make smaller colleges within the University of Michigan so that we can have this kind of engagement, because I think what we're getting down to here is talking about how terribly underfunded education is in our society. You should never have a class of 700. That's a TV show.
Yeah.
So let's distribute resources for the benefit of our people and our humanity, our future, our happiness, and all of this rainbow stuff that's very real.
I'm with you on that, John.
Oh, shut up.
Any other questions for Russ? I'm sorry, go ahead, Jim.
I was just wondering how long John's been thinking about this now.
All my life.
Well, one thing I find about modern education is it's so expensive for the individual student that many of them, are forced to drop out, are so mired in debt that they don't get out until they're 40 or 50, and that they don't start families and they don't start leading, what traditionally was adult lives, and until they've been able to pay off this huge loan. When I went to school here, $347 a semester. And help my parents and working summer jobs and the dorm kitchen, I didn't have any debt when I was done. Well, there was a $400 defense loan. They were handing out these little loans. That was the one thing I had to pay off. And I just can't imagine sitting in class and knowing that you're $4,000 deeper in debt for having taken that class, and that given all the other classes you have to take to get a degree, and that often the degree you get won't get you a job without a postgraduate degree. I wonder how much the discussion we're having really affects the real world of a lot of the students out there. Now at the university, even when I was going there, and it had something of an economic or class diversity, because it was $347 a semester. That now I can't imagine that there's going to be very many, kids whose dads work on auto plants and moms teach school that are going to be able to afford to go there. And
yeah, well, you may know that President Sissel, one of the things that he did since he's been here is to essentially make tuition free if for students in Michigan who's come from families that are making less than the median income, which I thought was maybe something like $65,000 or $70,000 a year. So, so there are some there is some movement to try to make the university more affordable, particularly for people from families who don't earn a lot. So that is happening, but it's still in the early days in terms of, you have to now convince people kind of put it out of their minds, like, I'm not going to be able to afford it, so why should I even think about it? And now they have to be informed that, hey, yeah, you might actually be able to manage. Is that if you tuition zero and maybe we're able to pay for some room and board, maybe you can come out with some work study, for example, come out with no loans, right?
Yeah,
be in a position like you were.
Yeah, that was because of tremendous support from the state. The tuition was that low.
Yeah. And that has largely evaporated. I think we're operating at about 15% of our budget is now coming from the state.
Yeah, and it was probably the other way around when I was in school.
Right. Yeah, it was back then. It was over 60% of the university's budget in the state.
Right.
So then you got the California model, where if you're a resident of the state, it's free.
No longer.
No longer. That ended.
Oh, that's right. Now that you as soon as that left my mouth, I thought that changed, didn't it?
Yeah, I think when it changed too.
Yeah, I could guess.
Reagan.
Yeah, I was going to say, it's got his stamp all over it.
Getting back to the grade inflation thing, Doctor, it's been very enlightening for you to speak about that. And I think the fact that there is controversy about grade inflation is become kind of philosophical, at least, issue in education. That how do we think of one another's learning? How does a person of your age or my age think of the intellect, the learning of a youth?
Yeah, well, I mean, I think the two words that I like to use are competency and mastery, right? And I think that when you're looking at competency, that's when letter grades are kind of useful, in terms of like as a signal. That's what they were supposed to be. They were supposed to be a signal, like, if you get an A or a B, if you get an A, you're really competent. If you get a B, you're competent enough. If you get a C, you're not quite there. And if you get a D, you really need to work, and that's useful, I think, at the for 1 and 200 level courses, like when you're just learning introductory physics and learning introductory calculus and all that kind of stuff. But once you're at the 300 and 400 level, certainly, in the graduate courses, I think grades are just stupid. I mean, everybody Rackham doesn't even recognize a grade lower than a B. So, basically all the grades are A's and B's, and it's, Lake Wobegon for sure. At the upper division, that's where the creative element should really be. I and others on the faculty really try to have more elements in the syllabus where students, instead of read this and then I'm going to test you on it, it's like read this and then fashion your own problem and create a solution, or read these 4 things and put them together and synthesize them and write about it. So it's much more creative, and of course then there's the whole creative side of the university, art and design, and that's a whole other way of self-expression for students. I mean, I think given you want to give our students who are approaching the end of their academic careers much more opportunity to exercise their creative juices and demonstrate to the faculty that I can do something new, as opposed to just going through the motions of preparing for the exam and taking the exam and getting a high grade. Yeah, okay, so I learned stuff that everybody else knows in physics. We just had a curriculum committee meeting today in the physics department where I don't even, it's getting late. Probably shouldn't, and this is being recorded and it's on YouTube. So I better just stop there because we're heading into TMI territory.
We almost got you.
And I just poured a beer, so I'm going to just shut up, zip it up, and but it's always hard to manage. You have to remember that the curriculum is managed in a collective endeavor by the faculty, and it's often very hard to get faculty to, faculty are very opinionated and typically very smart people, and it's very hard to get them to line up and say, 25 people in the room all nodding their heads, yes, this is the way we should go. Because inevitably you've got one in the corners going, nope, 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 or then another one starts going, nope, 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 and then it just falls apart. So, but what's important is that individual faculty as human beings interact with individual students as human beings and promote the benefit of everyone, right? And I think that's what you're really getting after, is that the students should feel like they've had an interaction, not just with the university, but with people at the university and formed relationships. And I think that a lot of our students end up, certainly in our department, a lot of our students end up feeling like they got a good deal in terms of forming relationships with our faculty. So I'll leave it on a positive note with that.
Thank you, Gus.
Thank you.
Okay, thank you for having me, and take care, y'all. Hope to see you in the flesh next time.
Yes, that would be nice. And I talk next time.
Thank you,
Yeah,
Gus.
a couple of things, Gus. You had mentioned in the email that you preferred to get one of our club hats.
Oh yeah, that'd be
So
great.
I wanted to show you, we actually have two different types here.
Okay.
This is more of a standard kind of hat that you've been familiar with, like a higher profile.
Yeah.
You'll see in the back, it is a stretch fit. It's got
okay.
elastic in it.
Yeah.
And there's two sizes. This happens to be a small medium. There's also, I think it's a medium large.
Mm-hmm.
And then we have another style, which is sort of an unstructured or lower profile.
Mm-hmm.
It's such that it's not as tall.
Yeah.
This just has one size, but you'll see in the back here, there's
like
an
those
adjustable
bundles.
strap.
I like that model.
Yeah, I think I prefer this one too. And it's different.
Yeah.
Everybody's got hats of the other type. This is kind of different, so.
Sweet.
Okay, probably our treasurer is going to send you one. If you could send me your address, I'll get it to you.
Yeah, I actually sent it in the email where I told you I wanted the hat. I put my address down.
Oh, okay. I just didn't catch that. So
yeah.
There could be some delay because he's in the process of, he's actually in Traverse City trying to get settled back in. So if there's a little delay, don't be surprised.
Yeah, no worries. No rush.
Yeah. So.
Yeah.
One other thing, and earlier in your talk, you had talked about the possibility that we could actually be living in a simulation, or the possibilities that we could create like another reality through a simulation, which reminded me of a movie that I really, really like. I don't know how many. Well, that doesn't help. Really reverse, does it? It's The 13th Floor.
Wow.
Yeah, I saw that. Yeah.
I don't know if any of you have ever seen it or not. But I think it's really, really good. It's science fiction, but yet the way they lay this out, you could actually see how this could possibly happen. But it basically deals with that, how we can create a whole nother reality. And then what's really cool is actually go in and interact with it. But it's not that simple. As you go along, there's a lot of twists and turns, and then you think you've got everything figured out until the last 2 seconds approximately of the movie. But anyway, I
don't spoil it. Don't spoil it.
That's what I said. Yeah, it's very entertaining. So with that, we're going to move into officer reports. So you can stick around if you want, Gus, or if you got other things you want to do this evening and want to move on, we certainly understand that too. That's up to you. So
yeah,
thanks again. We appreciate it.
Okay, thank you.
Okay. Yes.
So.
Okay, so I actually have nothing to report other than that. So I will move first to Adrian.
Believe it or not, nothing lowbrow wise. I know we have a discussion coming up about if we want to try and do members only things at Peach Mountain, but I'll wait to comment on that. David Levy, whom I'm now friends with, has a book for sale, and if anyone is interested in getting that book, I'm pretty much helping to broker it. You can send me an address, and if you're interested, and I'll send all of those to David, along with some money, and he'll send me all the books and I'll distribute them. So,
he really is a great guy, isn't he?
Yeah.
Yeah,
absolutely.
I got to know him fairly well when I worked with him, and I really enjoyed every minute of it. So, yeah, you can put me down for that.
All right, I will.
Okay,
So that's kind of our report.
that it?
That's it.
Okay,
That's it for me.
Joy.
Nothing. Thanks.
Okay, thanks for doing the minutes, much appreciated. How about Jim?
Well, mostly to relay Don's report. Our newsletter editor, Don Foley, is on vacation.
Except he's here.
Yeah, he's
Oh,
actually. He's actually.
he
To
is
your,
here. Okay. Then he can give his own damn report.
Yeah, I was going to read it too. Then I thought, well, we don't have to.
No, we don't. Yeah, there are a couple of things that the officers need to discuss, though I think our little crack of daylight in terms of possibly having members' nights on Beach Mountain, I think that discussion needs to go to the membership as soon as possible. There aren't many, nights left this year that anybody's going to want to do it, number one, but more importantly, that folks understand what's happening and why it's happening. And, we've got a few ideas about how it's supposed to work, but we don't have enough ideas about how it's supposed to work. It's a lot of tunnel vision, I guess, is the way I describe the discussion so far. We tend to look at things so intently from our own perspective and the problems involved that we see each as individuals as making things work. For example, you, I, and Charlie, myself, and Jack are the only ones with keys, so that means, and we're honor bound by the university to be the only ones in possession of those keys. This makes members' nights dependent on the three of us. And that's probably one of the bigger difficulties in making something like this work out. So that's just an example of things that maybe aren't so hard if somebody else looks at them besides the three of us, for example. So whatever of the non-officer membership that's still on the meeting, think about how the member nights have worked in the past and let us know how you think they could work in the future, given that, COVID is out there, because as opposed to up to now, we do have some ways into the university to be able to get some input to people, some of our input to people that matter, to make decisions about what the university is going to allow and not. So it's possibility is more real than it's ever been.
Yeah, exactly.
During this mess that we might be able to use Beach Mountain again for observing.
But like as Jim suggested, on a very limited basis, and would really have to be members only, because I think if we tried to get public involved, it would totally get away from us. So
yeah, we could have a gunfight over a mask.
Oh yeah, yeah.
Jim, all you have to do is go to the times where we went to personally observe and watch how the public behave. That's enough for me to know that there's just really no chance. If you announce anything and the public thinks that, Peach Mountain is open, you're going to get a lot of maskless folks breathing in your face, asking you what you're looking at. And can I look through your telescope? That's just a natural fact. It's nothing really you can do about it. It's just the state of where things are. And
I agree. Most of us who organize these things have come to that conclusion that we just can't do public events.
Yeah. If safety is your concern, then a lot of it is slowed down because things are not in the media now like they used to be. I think even Mars, I haven't seen much in the media, but now all it'll take is the typical 2-week lag of the media. Expect something coming out about Mars, I would say, in the next couple weeks, and all of a sudden the public will want to be outside again. So we'll see if my prediction holds. But I know Mars.
Weather tends to slow things down for us in terms of the public, and always has.
You know, it doesn't stop media. It doesn't stop social media from putting it out there. Remember the comet was here about 1 or 2 weeks before news started going out, and all of a sudden there was barely any parking space in any of the dark sky park or any of the other places.
Yeah, 65 or 70 degrees at night is a lot different from 35 or 40.
That's
true. What people are willing to do. But yeah, I agree with you that, especially a comet, people are, go bug-ass crazy over comets and Mars. And so, we don't want to stick our heads up.
Right.
You do bring up a good point, Adrian. Media seems to be slow this year. I really expected they'd a couple of weeks before opposition be all over it, and the usual kind of thing that, you've got to be out one particular night or you're going to miss it all. And they really didn't this time.
I think our president having COVID-19 had a lot to do with that. The timing, the news made more sense to report on the president. Mars doesn't care about the president, and so it went into opposition, and we knew we were concerned about it, but the media may not have seen that as a viable thing to post when you have this other news going on.
Yeah, Ani sent out a photo of Mars that he stacked, and he was out the same night I was observing at Wesley Park, and it's remarkable. What he got is what I saw. So,
how busy was Wesley Park? Was it back to being sparse?
Well, it was a relatively warm day, and the tennis courts were busy when I got there, so there were a lot of people there. But once it started to get a little bit dark, everybody disappeared, and I was pretty much the only person there.
Nice.
So, especially I think during the week, and if there's nothing exciting going on, or like the comet got a lot of people out there in June, and that was just bad news as far as the virus went. But I think just for normal observing, if you want to go out there, I don't think you'll find too many people. And if you've got some aperture, you can see a lot.
Yeah. Yep. That it, Jim?
That's it.
Okay. How about Don, who can do his report live after all?
Hi, all. Yeah, my comment, the view that I had through Mars, this opposition of my 10-inch is the best view of Mars I could ever remember having. I saw Mars with the surface and such, and that little teeny ice cap. It was fantastic. My report has changed a little since I sent that note to the officers, because Adrian and Brian and Liz have all offered to give me articles this week. But I always encourage membership to get creative and create articles for me. I prefer to publish things that haven't been around in emails before. So I do have some content for this month's newsletter.
Good.
Say, when you see my video, is like the word Pluto backwards?
No.
Nope.
Pluto's fine.
Okay. In
Like
my monitor, everything's reversed. So I never used this tablet before. I wasn't sure I could connect with this tablet.
Well, then I'm curious. Is that mirror image?
No.
No, it's not.
Okay, yeah, so it's just my view.
All right, just curious.
Oh, Don, how are you feeling?
Since I sent that email out, I'm feeling a little better now. I was really worried that I may have damaged something in the shoulder. Still a little worried. I can lift the arm up about this far now, but I don't dare move it any higher. But I think
you need to see somebody, Don.
What?
You need to see somebody. If you can't lift your arm.
Well, when I get home, if I don't have the full mobility by the time I get home on Monday, I will.
Okay.
But I'm encouraged with the improvement that I've had in the last 24 hours.
That's good.
How did you do it?
I was sailboarding yesterday afternoon. Yeah, and I was tacking and I took a fall and I didn't let go. It's a long story. You're supposed to hang on to the boom, but I'm with it. I was going to do that, but then I lost this hand, so I'm going down with the boom in one hand. And I landed on my hand with the boom in it, right into my shoulder. So I'm a half mile out of the water. How the heck am I going to get back to shore? Fortunately, the water's only this deep. I said, well, I can walk it. But I managed to jump on the board, get on the board, and I actually used both hands to haul. Got the boom in my hands. Some breeze came up at the best time, and I hooked into my harness, and I leaned back, and I cruised right back. So I got back pretty readily, pretty easily.
Nice save.
Anyway, and if I didn't know if I could spend time typing like this with this arm. It's smooth when I try to raise it like that. If I have trouble, Jim's volunteered. So, but I've got a week or so before I need to start on it. So we'll see how.
And well. Okay, that it, Don?
That's it.
Okay, how about Jack?
Well, the big news out at the observatory is the road up to the radio telescope. They did grade it and finish it and level it. I was out there a couple last week and looks good. So that's an accomplishment. So we'll just, if later on in the year we do come up with some type of members only open house, at least the road is repaired and it is drivable. So that's the important part. Other than that, I think everybody already knows that we've painted the building and everything. There's an article and newsletter about that. So I really don't have anything else to say right now.
Okay, thank you, Jack. Doug, our treasurer, is obviously not with us tonight because he's still in the process of moving. But he did email the office with a report, and that is, quote, my report is that I have nothing to report, other than we move into our new place this weekend. Within a couple of weeks, I should be back in business. I'll send an announcement to the membership when I am. That's it from Doug from Traverse City. And with that, our very newest officer, Jeff.
Well, my inaugural meeting here had some technical issues on the sound on YouTube, but we got them fixed up by about 8 o'clock or so. Unfortunately, the first half of his thing was cut off, but I'm recording it, so we'll see if we can't patch together something. The good news is that we got 6 concurrent viewers and about 17 playbacks during this thing tonight. So the other little bit of good news is at the beginning of the video, we have we're waiting for things to begin. Please hold tight, and we had a little carousel of pictures and whatnot, and for people to look at, so they weren't completely bored waiting for us to start. And thanks to Brian Autumn for telling me how to do that. So I have more things to add to my checklist, and other than that, I think that's about all that's happened since I was tapped.
So maybe you said, Jeff, and I didn't quite catch it. Do you think the lack of sound affected the recording or just the live feed? It
was the YouTube piece of the feed, and it was only the audio. They got all of the graphs and pictures and whatnot, And the 5 people that were online during that period were very they were Suniva Collins and another Collins, Christina Collins. They were both very good sports, and we're going to give them free tickets to their next Lowbrow presentation.
Oh, cool.
Yeah, I know. It's a real discount price there. So
I know, and it's easy to multiply by 0.
yeah, they were excited about it. So, but I think.
How come I paid $10? I'm not getting that.
Darn.
You're an officer, Adrian. You're special.
You can afford it.
Now the good news is though
I can't afford anything anymore.
The good news is I did find where the problem was, and it's yet another thing to add to the checklist for the pre-meeting technical checks. So live and learn.
OBS sound audio is not disabled.
Yeah. Yeah, the screen I pulled up.
I didn't do that for ATB. You made me look bad, Jeff.
Yeah, all of the audio channels were disabled. And once I found the screen that I was supposed to, it's like, what? So I had to start and stop the stream, which YouTube kind of paused and said, what's going on? And then we got sound, and everybody was happy again. So apologies though, but it'll work better next time.
Yeah, great work as always. Finding the problem, I wasn't sure we were going to find it.
Oh.
But we won't do it the corporate way and like forbid you from touching it a week out before the meeting. But some kind of test might be a good idea though, just for something quick.
You know, I ran all the tests a week ago, and I haven't touched it since. So something reset in between that I didn't realize. So we'll do a full test next time around.
Well,
live and
means
learn.
You can't shut down. Once you test, you can't shut down your machine in between.
That's true. You'll have to run it forever.
You have to run the machine until it's done. Shut your machine down.
Better have battery backup too.
Those are allowed either. So you got to put it on a UPS.
Yes,
well,
UPS on that.
It runs off a line power, and I don't even log out of my U of M ID on this thing. So it's my work machine, and I just let it go. It's like, leave it be. Everything will be fine. Ha ha.
I always blame everything on an update.
I'm going to go with that.
And that would be quite accurate, Joy.
That would be nice, except you run Linux. You can not update, and it usually runs fine. Other OSs, you're forced to update.
Yeah.
No, when they complain at work, I say, oh, it must have updated that way now. It's just going to be like that. You're stuck with it.
You're running Windows up there, so yeah, that makes sense.
I have a Mac. It upgrades nicely. It's OBS that was the issue. But no big deal. We'll fix it for next time.
I just want to say, Jeff, I'm going to get together with you and Bob Trombley from the Warren Group, and we're going to nail down this YouTube thing, because I have 2 other organizations that want to do YouTube meetings or YouTube presentations on Zoom meetings.
Okay.
So we're going to have to get good at this and get it down to a process. And the other thing I wanted to mention is that up here in Livingston County, we have this Lux Park, which the county has designated as a dark sky park.
Ooh.
The Ford Club, what's the fellow from Ford Club? Finn?
Liam.
Finn. Yeah, Liam Finn. I guess he's been working with the people in the Livingston County Parks on this, and I hope to, that would be a good article for the newsletter. So we do have a dark sky spot in Livingston County, and I'll try to get something out about that soon.
Cool.
I just want more information on it, John, so I can pay it a visit and take some pictures maybe to add to your article.
Well, we'll see how good it is.
Next.
I would love to have the article for the newsletter.
Yep.
And we can do it in December.
It's coming.
All right. Does anybody have anything else? Do I hear a motion to adjourn?
Motion to adjourn.
Support?
Seconded.
Alrighty. Okay. I assume nobody's opposed. I don't see Doug Nell hanging out, so. Okay, have a nice evening, everybody. Thanks for coming.
Thanks.
Good night.
Thank you. Bye.
Okay. For what it's worth, Charlie, the presentation quality is getting better and better on this whole thing. So I was a little surprised by the sound issue today.
Yeah, I noticed, was it last time, we had a couple little times when the, if that's what you're speaking about, the audio and video got a little funny.
No, this time the audio was completely missing.
Well, on the YouTube feed, yes.
Yeah.
But I noticed even in the Zoom session, it was, maybe it was just on my end.
I didn't notice anything last time. This time around.
Okay, maybe it was just my
yeah.
end. So.
Yeah, I just it was one of those things where when I was testing, is one of the audio mixer went away, and I was like, well, okay, and I put it back and thinking everything was going to be fine, and everything seems to work the same way, and all of a sudden we're not getting any sound. It was like, that's odd, and well, there was a lot of panic going on while Gus was speaking, so.
Well, you were just earning that big money we pay you, right?
Yeah, the salary is compulsory, so.
Okay. Yeah, here in Cape Hatteras, the very first part of his presentation was all frozen, and the audio was all garbled and missing, and it was being, my system was resetting and reconnecting every 30 or 40 seconds. But after 5 minutes or so, everything settled down and it worked real well.
The recording has stopped.
Bye, gang.
Yep. Have a good weekend.
Have a good one, Jeff.
Yep, we will. And we are gone. Where's my screen?